instructional algorithm, because it's just more simple for me, I guess. So what I did is we have 10 times 20, so that would be 200, and since like the 2 is smaller than a 6, you don't have to change that, it's already in basics. And then you do the 10 times 3, which is 30, and again this is smaller than a 6, so we don't have to exchange. And then you do the 4 times 20, which would be 80, but then that's past 6, so we have to exchange one over here. That would leave 2 left, which is 0. And then we have the 4 times 3, which is 12, and 2 6s can go into that, so we exchange 2 over here, and there'll be a 0. And you just add that together, so these are all zeros. And we have 3 plus 2 is 5, plus 2 is 7, which means that we're going to exchange one over here, there's 1 left over. And then we have 2 plus 1 is 3, plus 1 is 4. So we have 410.
Anybody have any questions for her?
Any questions?
You may or may not have had time to check the problem, but how would we check it?
Converting it to base 10.
By what?
Converting it to base 10.
Convert both of the numbers to base 10, and then you could convert the answer to base 10 and see if it matches. Okay? All right.
Being in a hurry, I just did the standard algorithm, so I said 6 times 5.
Now I'm curious. You say being in a hurry. Why would that?
This is standard's a lot easier for me than this. It takes me longer to think that through because it's not in my head already.
Okay.
And the 5-minute time.
Okay.
But then I found that I was done very quickly anyway. But I did 5 minutes. But so 5 times 6 is 30, and I say to myself, how many times can 7 go into 30? And it can go 4 times. 4 times 7 is 28. So I said 4, and then with 2 remaining, so I put the 2 there. And then 4 times 6 is 24, plus 4 is 28, and 7 can go into 28 4 times with 0 left over. And then 3 times 5 is 15, 7 can go into 15 2 times. So 2 times with 1 left over. I have my 0 there because we're going right there. Okay, where was I? So that was 15. Goes in 2 with 1 left over because of 2 times 7 is 14. And then 3 times 4 is 12, plus 2 is 14, and 7 can go into 14 2 times with 0 left over. And I'm just adding that.
Questions? What could you use besides the standard algorithm or the instructional algorithm? Lattice would work very. Did anybody use lattice? Lattice works very nice. Keeps it organized. What else? Chinese. As long as you remember you're in that other base. How about Russian? Peasant. Having and doubling in another base isn't as easy as it is in base 10, so that may not be any advantage at all. Okay? All right. Well, I want to talk to you about the problems that showed up in your in that paper I gave you right at the beginning of the unit. The questions were, well, before we go there, let's everybody grab your blocks. We're going to model division with blocks. let's do a pretty easy problem here. In base 10, 12 divided by 3. How could we do that? How could we divide 12 by 3 using the blocks? Does everybody have a partner to work with? You guys working together? You might check in with somebody there to... Anybody have an idea how we could do it?
You just take 12 grams and divide them into 3 equal groups.
Okay. We could say, I've got 3 people I'm gonna share with, right? So I start with 12, and my 3 people are 1, 2, 3. I still have some left, so I'm not done sharing, right? I'm still have some left. 3. Then 1, 2, 3. What model is that one called? The partition or sharing model. We know the number of partitions, sections. We know the number of groups that we're going to divide it into, and the question is how many go into each group. That's what the partition model asks. Number of groups known. Question is how many in each group. And the way you solve that is you just share out until you are out of blocks. When you're out of blocks, you're done. Now, if we had one like 7 divided by 3, okay, that says I've got how many to start out with? 7. And I know how many groups I'm going to share with? 3. Right? So, I start sharing. 1, 2, 3. Am I done? No. 1, 2, 3. Am I done? No. Then what do? I don't have enough to share one with everybody else.
So you've got a remainder of 1.
I have remainder 1. That's one way to think about it. Or what could I do?
Divide it into 3.
Did you watch the cookies thing? Grab my cookie cutter. What am I going to cut it into? Thirds, and then I'll give each one a third. So one answer is 2 1/3, and one answer is 2 remainder 1, depending on what our situation is. One of those might make more sense than another. That is what we call our partition method. All right. What's the other model?
Repeated subtraction.
Repeated subtraction. Partition is also called sharing. Repeated subtraction is also called measurement. In this one, instead of knowing the number of groups, we know how many in each group is known question is, how many groups are there? So if we go back to the original problem of 12 divided by 3, we should always start with the dividend, with both models. The sharing one, we share one at a time until they're all gone. Then we know we're done. With the repeated subtraction, what I do is I know how many in each group. This is saying how many groups of 3 are there in 12. That's a different question than how many does each person get if there are 3 groups. It's a different question. So I'm going to break off 3, break off 3, break off 3. I'm subtracting repeatedly the divisor amount. When am I done? When I'm out of blocks. What is the answer? How many piles of 3 I got? How many groups of 3 I got? Does that make sense? Does everybody see why we're using 2 different models? That's not the same kind of thinking. All right, let's do this second one that way. Repeated addition with this one says what?
You mean subtraction?
Repeated subtraction. Yes, thank you. Repeated subtraction model for this one says break off. I know there are 3 in the group. 3 in the group. And now there's not 3 left in the group, right? Actually, there's 2 groups and a third
Could be a half.
of another group. Right? Because my groups are of size 3, so this is a third of a group. So I got 2 and 1/3 is one answer. 2 remainder 1 is another answer. How do I get a third? We divide this. Goes in there twice. 6, 1, bring the 0 down. Goes in there 3, 9, 1, bring the 0 down. 3, 9. Can everybody see that that's going to keep repeating? What is a 3 with a bar over it?
1/3.
1/3. Because I have 2 full groups of 3 and 1/3 of another group. Does that make sense? I also have remainder 1. Okay? Okay. Questions about the 2 models? And here are the problems I gave you earlier. Take this problem and help a 4th grader understand it. What is the answer and why? Use your blocks, use your partner, talk about it.
So you have your 0.
Well,
The very first division, you have something,
Yeah.
worked a long time ago, the very beginning, like of this.
Try both models. Try to make sure to do both models. See if you can make sense of both models.
Basically, we have, no, with 5 groups, Nothing. When you distribute nothing evenly. So it's zero.
Who can explain one of the models?
How do you explain that to you?
With
Nobody?
our partition.
You have 0 and you're trying to divide it up.
I've got 0 right here. There they are.
You have 0 and you're trying to divide it into 5 different groups.
Okay? So here I go.
Yeah,
5 different groups. Right?
yeah, but there'd be any number of things in that group, in those groups.
When do I stop?
You don't know. It could be any.
When did I stop here?
When you have no more left.
When I don't have any left. So that's when I should stop now, right? So I stop as soon as I start, right? What was the answer to this
Is 0.
in the partition?
How many are in each group?
How many were in each group? Okay, I got 5 people here. They're all waiting for these cookies that I have. I have 0 of them, and I go up and, whoops, I'm done because I'm at 0. The question we ask is, how many did each group get? How many cookies were in each group? How many are there? 0. Right? That's using the partition model. Now, let's use the repeated subtraction. Yeah, question. Oh, you want to do it?
Yeah.
All right, go.
So, you have your 1, and then you would take, since you're divided by 5, you take 5 out
So I pop off 5
Yep.
each time
each time, and then you keep going until you run out, but
till I run out. But I've run out, so the question, what question gets answered when we're doing the repeated subtraction model? How many groups did we end up with? Well, I had to stop when I got to 0, so guess what? I've got 0 groups. There were 0 groups of 5 that I was able to get. Does that make sense? Now there's a third model for division. What is it? Missing factor model. The missing factor relies on the fact that every multiplication or division problem is a member of a fact family of how many members? 4. We'll just take that top one right there. 12 divided by 3 equals 4. Give me the other members. 12 divided by 4 equals 3.
4 times 3 equals 12.
4 times 3 equals 12.
And 3 times 4 is
3 times 4 equals 12. Every fact family in multiplication division has 4. 2 of them are division, 2 are multiplication. On the multiplication, the only difference is the order of the factors. On the division, how do they change? The dividend remains the same, and we swap places with the divisor and the quotient, right? So, help me with this one right here. If I don't know what the answer is, help me rewrite a missing factor problem from the same family.
So it'd be 5 divided by 0. You technically cannot, but that's how you would write it out at first, and then you'd cross it out.
5 divided by 0 is a member of this same fact family?
Right, and then you put a...
Is it? Look at the pattern.
It is. According to the pattern, that's the way it is.
According to the pattern,
Who keeps the 0?
the dividend is always the same on the divisor problems. This is not in this same fact family.
So like,
It may be another fact family, but it's not this one.
0 divided by 0,
0 divided by 0 is
5.
5. Is that it?
That's not true. It's not.
0 divided by...
That's what should
How do you get the other members?
You just. So 0 divided by 20.
0 divided by blank is 5. Is that the right?
Yeah, because we don't know if that's 0 technically. When filling out the factor tree with the original problem, we don't know the answer is 0. So it'd be question mark.
Oh, yeah, blank. Right?
Yeah.
So now it'd be
but can 0 divided
What's our times ones?
0 divided by anything equal 5?
5 times blank.
You what?
5 times blank equals
5 times blank equals 0. Do you remember when your teacher gave you these problems? She says you can always check your answer by taking the quotient times the, to get the, right? Okay. Is this a member of the same fact family? How about, what's the other one?
It'd be blank times 5.
Blank times 5 equals 0. Well, what do I put in here?
It'd have to be 0.
0 and 0, correct? If this is true, then this also must be 0.
The second one isn't possible.
This one is not. Yeah. The multiplication problem, to check it, what times 5 is 0, right? Okay. Let's try the next problem in that list. 5 divided by 0. Use your models, partition, repeated subtraction, or missing factor, to try and explain 5 divided by 0. Start off with 5, just like we started off with 12, okay? Which model are you going to use? When do you get done? Think it through.
Partition 0.
It's not just it's undefined.
Okay, but 0 divided by 0 is not defined. 5 divided by 0 is not 5.
Because we couldn't
Just divided by a lot of 0 people.
But I just can't figure out why
Who's got it? Who can do it?
It's not possible.
Let's start with partition. I start with 5. I know the number of groups. They're known, right? How many groups?
5.
0 groups. There aren't any groups, right? So I go to share, but there aren't any groups to share.
Which makes it undefined.
Why?
You can't share.
When do I stop?
You stop right away because there's no groups.
You stop when you run out. I haven't run out yet.
But there's no groups to
But there are no groups to give it to.
Right. So it's
Therefore, since I can't give it to any groups, and I can't stop, because I'm not done,
wasn't defined.
it's undefined. Does that make sense?
Makes the most sense.
We started with 12. There were 3 groups. When did we stop? When we got all of our blocks gone. That's when you stop with partition. But we can't stop because I still have 5. But I can't get rid of them because there's no groups to pass them to. So I will never get done. Therefore, this is undefined. According to the partition model. Let's take the repeated subtraction model. Start with 5. How big are each group? 0, right? So I break off 0, lay it in a pile. I'm going to count how many piles I make, right? Because that's the answer. When do I get done in this repeated subtraction?
You get to 0.
When I get all my blocks gone. I've snapped them all off. Okay, I keep breaking off 0, putting them in these piles, but I'm never going to get done because I'll always hold 5 in my hand because I'm only breaking off 0. So since I can't get done, it's undefined with the repeated subtraction. Does that make sense? It's not just something that you memorize, it's something that makes sense. Let's go with this, missing factor. Somebody give me a multiplication problem that is in the same fact family that has missing factor.
Blank times 0 equals 5.
Blank times 0 equals 5. Let's figure this one out. What number could I multiply by 0 and get 5? There's no such number, right? If you multiply by 0, you get 0. There's a third way to show that this is an undefined problem. Does that make sense? Before you came to this class, you probably had memorized you can't divide by 0. Now you should be able to explain why you can't divide by 0. You should be able to explain it 3 different ways. One with the missing factor model, one with the repeated subtraction model, and one with the partition model. Okay? The next problem was 0 divided by 0. What goes in the blank? All right, do it with your blocks. Nobody's picking up any blocks. What's happening?
We just proved that with 5. So you can't do 0 to 0. So you always have 0. You get subtraction, you can't subtract 0 from 0. Take away 0, you always have 0. Multiplication line, 0 times 0 is 0.
Both of these for partition and repeated, you would stop before you started because you had to have 0
Who can explain it?
to start with.
What's the answer and
It's
why?
undefined.
It's undefined?
Yep.
How?
Because you're starting off with 0. And you
I've
can't
got 0 blocks.
You can't give away anything from 0.
We know the number of
Sure. Groups.
groups. How many groups are there?
0.
There are 0 of them. Okay, so I'm going to snap off.
But you can't. There is no 0. There's nothing to snap off. There's literally nothing in your hand to snap
Okay,
off.
so I have to stop.
Yeah.
So what's the answer?
It's undefined.
Why?
Because you have nothing to give away, nothing to add to. Because it's both 0s.
I was thinking that it would equal 1. I'm not sure, but because when you divide a number by itself, it equals 1. So you're doing 0 over 0.
Except for when it involves 0. You cannot divide
Yeah.
anything by
Maybe
0.
maybe it is 1.
just like infinity divided by infinity is not 1. It
Well,
is
but-
undefined.
But infinity isn't a number.
Right.
And 0 is a number.
It's not.
Yeah?
It's
Well, if you look at a fact family, you can do 0 times blank equals 0, and anything times 0 is 0. So it's going to be an infinite amount of numbers. You could have 1.
You're jumping to this one?
Yeah.
Okay, let's jump to that one. Give me the multiplication problem.
0 times blank equals
0, this 0, times blank equals this 0. That's the same fact family, right? This one is that one, if you look at the pattern. So what are you saying?
anything times 0 is 0. So it's
So 1 could be the answer. Right?
But it could also be 100.
Yeah.
Oh my goodness.
Or it could be negative 100. Or it could be the square root of 7. Right? This problem here is undefined because there is no such number which I can multiply by 0 to get 5. This one is undefined because there's no single unique number. Does that make sense? They're undefined for different reasons. This one is because there is nothing I can put in this blank that will make it true. And this one because anything I want to put in the blank will make it true. Okay? Let's see if we can get this one back here. Let's try a repeated subtraction. I've got 0 here in my hand. How many should I break off? 0 each time. Broke it off. Broke 0 off again. Look, 2 groups. 2 is my answer. Nope, 3 groups. 3 is my answer. Because see, I've got 0 in my hand. When do I stop?
Tell you when you get to 0.
When I get to 0, right? But I can do 5 groups of 0 and have 0 left, right? Or I can have 10 groups of 0 and have 0 left. Does everybody see it?
It's the same thing because you have there's
There's
many.
many answers.
Yeah.
Okay. Okay. I want to talk about division. What is it? Well, we've defined it. One of the models is repeated subtraction. What happens is, let's just do this one. 75 divided by 6. One thing I could do is, I could go minus 6 and get 69, right? And I've taken out 1 6. And then I could take out another 6, go to 63, and I've taken out another one. Go to 57, take out another 6. And I could keep doing that, right? Taking out 4 6s now. And when I get all done, I just add up how many 6s I took out. Does that make sense? Somebody said that is way too long. Repeatedly taking out 6s. Why don't we take them out in bigger chunks? Take them out in bigger chunks. So watch this one. I happen to know, because it's a real easy fact, that 6 times 10 is 60. So I'm going to take out 60, which is how many groups of 6? 10. That leaves me with 15. Then I could take out a 6 here, leaving me with a 9. Take out another 6, leaving me with a 3. And my answer is 12 with a remainder of 3, right? Or 12 with a half of a 6 left. So it would be 12.5. Does everybody see how I'm getting that? I'm repeatedly subtracting. The algorithm developed by trying to take out as much as we can. Now notice I took out these 6s separately, but I could have done this. I know that 6 times 2 is 12. That's taking 2 of them out, right? And that leaves a 3 left, and so now my answer is 10 and 2. Plus a remainder of 3. Now, the instructional algorithm for division works like this. I take, this goes into here, and I write how many times that was. 6 goes into 75 10 times. And then I have 12 left over, so it goes in 2 times. I write the 2 up above that. And then as soon as I get down to a number that's less than the divisor, I stop. That's my remainder, and my quotient is this plus that. Does that make sense? So you stack it up, and then just add it up. And it's based upon the fact that it's repeated subtraction. But I'm taking it out in big chunks, not one at a time. Okay, what about division in another base? You ready? Let's try 3 into 2301 in base 4. You ready? I suggest before you start your division problem that you write down your multiplication facts in the other base. I'll show you why. Since I'm dividing by 3, I go 3 times 1 in base 4 is what?
3.
3, because 1 is the multiplicative identity even in other bases, right? 3 times 2 is what? 6, which is what?
It'd be
1 group of 4 and 2 left over, right? 3 times 3 is what?
Be 2, 1.
2, 1. 9 is 2 groups of 4 with 1 left over. You with me? How far do I need to keep going?
Till we get up to 2, 3, 0, 1.
No. This is it. Because I've done 3 times 1, 3 times 2, 3 times 3, but there is no 3 times 4 because there's no such thing as a 4 in base 4.
Right.
I'm done. Now watch how slick that makes it. 3 won't go into 2 because it's not big enough. 3 into 2, 3. Now notice it's not 23.
It's 2, 1.
And I say, hey, it'll go in 3 times because 2, 1 is less than 2, 3. So I put up a 3 up here because that's what gave me that. And 3 times 3 is 2, 1. Everybody see what I've done? Now I subtract in base 4. That's still a 2. Bring this down. Will 3 go into 2, 0 3 times? Nope. 2 0 is not big enough, right? But it will go in twice because 1 2 is less than 2 0. So I put a 2 up here. I don't need to even worry about multiplying. I've already got the answer over here. It's 1 2. Subtract. In order to subtract in base 4, I don't have enough. I come over, exchange, making what?
4.
That's a 4 instead of a 0 now because I went over and got 4. 4 minus 2 is 2. Bring the 1 down. 3 goes into 2, 1. 3 times. 2, 1. Remainder of 0. There's my answer. Okay, how can I check it?
You transfer everything to base 10.
I could convert this number to base 10, this number to base 10, divide with my calculator, and then convert that answer to base 4 to see if that's it. How else could I do it?
Couldn't you just multiply your answer by
Yes. We can take our quotient and multiply by the divisor, and that should give us the dividend. Let's try it. 3 times 4 is?
Is it supposed to be 4 or is it supposed to be 3?
It's
You might.
What was I thinking? I miscopied that, thinking base 4 and wrote 4. Thank you. 3 times 3 is 9, which is 2 groups of 4 with 1 left over. 2 times 3 is 6, plus 2 is 8. That is 2 groups of 4 with 0 left over. 3 times 3 is 9, plus 2 is 11. 11 is 2 groups of 4 with 3 left over. There's another way to check it, which might even be faster than converting them all into base 10 and seeing if that works. Okay? It's just like when you're subtracting, you can take your difference and add it to the subtrahend to see if you got the minuend to check your subtraction in another base. Let's let you try one on your own. You ready? Let's do 3, 2, and let's go 4, 0, 1, 2, 3. Okay.
Quick question. I think I just figured out a more simpler way to do multiplication of base 4. And I don't know how in the world I figured this out. But if you look at 3 times 1, that one I'm not going to worry about. But if you do 3 times 2 times 2 again, you get 12. And then if you look at the last one, 3 times 3 times 3 is 21. I don't know if that has any relevancy whatsoever, but
What do you...
I don't know. I just
3 times 2 times 2.
Yeah.
So 3 times 2
Oh.
is 6, times 2 is 12, 3 times 3 is 9, times 3 again is 21.
In base 10.
27, sorry. I don't know if that had any correlation at all, but
So 3 times 2 is 1, 2. If you take that times 2, you get 2, 4.
no, I was just talking about like in base 10. 3 times 2 is 6, times 2 again is 12. But you still get the same answer in base 4.
I'm not with you.
I don't know.
You may be onto something, but I'm not with you.
Okay, so just like in base 10, 3 times 2 is 6, times 2 is 12. It so happens that when you do 3 in base 4 times 2 in base 4, you get the same answer. I don't know if there's any pattern or anything.
Oh.
Maybe it's just somewhere. I don't know.
So what should we start out by doing here? Your times tables. I don't know that you need to write this first one down, because anything times 1 is itself, right? Did I make any mistakes? How far do I have to keep going?
Just the 4.
Till the 4, because there's no 5 in base 5. So that's all I need to do. Now, 3, 2 won't go into 4. Will it go into 4, 0? Yes. How many times, looking at our answers? 1. And we know the product here, right? Subtracting, come over, get a 5, that's a 3. It's smaller than my divisor. Bring the 1 down. It won't go in 1 time, so I put a 0. And bring this down. Now, this number is even bigger than that one, so it will go in 4 times.
1044, the remainder of 10.
4 times 2. Oh, we know the answer. It's 2, 3, 3. Can't subtract. I come over and get a 5. That makes that a 7. Can't subtract, come over, exchange, get a 5. 5 minus 3 is 2, 4. 2, 4 is smaller than this, so I'm good to go. Down comes a 3. 2, 4, 3 is enough for 3 more to come out.
Can you take 4 out?
It'd be 4.
Yes. I would have caught myself when you compare your
Answer to your...
remainder with your divisor. If it's bigger, then you didn't take enough out, right? 4, and we know that is 2, 3, 3, and that's just 1, 0
Base 5.
in base 5. So my answer is this remainder, this. Let's check to see if we did it correctly. How? Multiply. 2 times 4 is 8. That's 1 group of 5 with 3 left over. 8, 9, that's 1 group of 5 with 4 left over. 2 times 0 plus 1 is 1. 2 times 1 is 2. 3. Placeholder, we've got 3 times 4 is 12. That's 1 group of, no, that's
2 groups.
2 groups of 5 with
2 left over.
2 left over. 3 times 4 is 12, plus 2 is 14. That's 2 groups of with 4 left over. 3 times 0 is 0, plus 2 is 2. And then 3 times 1 is 3. 3. 4 plus 2 is 6. That's 1 group of 5 with 1 left over. There's 6. That's 1 group of 5 with 1 left over. 5 is 1 group of 5 with 0 left over, and that's a 4.
Something's wrong.
No,
Something is wrong.
But we have a remainder of 10.
But I have a remainder of 10, and so I'm going to add it in. 3, 2, 1, 0, 4. And that's it. So you multiply by the the divisor by the dividend and add the remainder, and that should give you, excuse me, the quotient times the divisor plus the remainder should give us the dividend. Okay? That's about as hard a one as you'll get. If you'll make sure your blocks are all neatly put in your bags and stacked back there in the